Today we're going to begin Unit 5. This is Lesson 1, and this is a review of radicals. We have to make sure that you're very comfortable solving radicals from Chapter 1 or Unit 1. So this entire section is going to be review. If I give you the square root of 625, the first thing you're going to do is take the square root of the number, if it's possible, and the square root of 625 is 25, so we would bring out the 25, and left inside would be that square root of x. In this one, if I break down the 63, that is 9 times 7. Square root of 9 is 3, so I can bring a 3 out. To simplify the variables, I'm going to take the root number, which is 2 here, and I'm going to divide the exponent by that root number. This is a root of 2, so 3 divided by 2, that goes in one time, so you can bring out 1a, and that means there's an a left over on the inside. That 7 was also left on the inside. I'm going to go ahead and put that down. 2 goes into 4 twice, so I can bring out 2 b's. And 2 goes into 6 3 times, so I can bring out 3 c's. And that stuff is left underneath the radical. For this one, I am allowed to rewrite that as the cube root of 16 over the cube root of 64, and then simplify the numerator and denominator separately. So the cube root of 64 is 4, so that's pretty easy. 16 can be broken down, it's 4 2's, so 2 times 2 times 2 times 2. So I can bring out a 2, and I have left inside a 2. And then this 2 and that 4 cancel, so that's the cube root of 2 over 2 on the bottom. And for this one, the fourth root of 243. 243 is the same thing as 3 times 81, and 81 is 9 times 9, and each of those 9s break down into 3's. So we can bring out a 3, and we have a 3 left on the inside. So that's 3 times the fourth root of 3. If we have a coefficient or a number in front of a radical that has a fraction underneath, remember we write that number as 2 over 1 in this case, and then we rewrite the fraction part as a numerator and denominator. Here the cube root of 1 is just 1, so we have 2 on top, and then the cube root of 5 on the bottom. And remember, you're not allowed to have any radicals on the denominator. So in order to get rid of that, we're going to have to multiply by the cube root of, what do you think that would be? The cube root of what? We need 5 3 times, so 3 5. So we have 1 5 here. I'm going to need 2 more, okay? So hopefully you're saying we need to multiply by the cube root of 25 on the top and bottom. And when we do that, we have 2 times the cube root of 25 over the cube root of 25 times 5 is the cube root of 125, which is 5. And that's our goal, to get rid of the radical on the denominator. For this one, if you have 2 radicals multiplied together, you could either simplify the 2 radicals first and then multiply, or you can multiply first. I tend to multiply first because most of the time it's easier to do that. So if I multiply first, that's going to be the square root of 300. And then I know 300 is 3 times 100, and 100 is a square number. So I can bring out a 10, and I have the square root of 3 left inside. For this one, 1 over 25, the square root of that is 1/5, so I'm going to go ahead and bring that out. My root number is a 2, so I'm going to divide the root into each exponent. So 6 divided by 2 is 3, so I bring out x cubed. 12 divided by 2 is 6, so I bring out y to the 6th. 10 divided by 2 is 5, so I have z to the 5th. Any exponent that started even and ended odd needs absolute values, so I need x cubed in absolute value and z to the 5th in an absolute value. This is very similar to this one here, but we have cube roots instead of square roots, so I'm still going to multiply them together. So I've got the cube root of 10 times 100 is 1,000. A cubed times a to the 4th. Remember, we add the exponents, so that's a to the 7th. b to the 4th times b to the 5th is b to the 9th. C to the 5th times c to the 7th is c to the 12th. Remember, or you see now how all of these rules combine and they go together in all of these problems. None of the rules are going to change. They're all going to be consistent, and we're going to have to use them within all of the different processes that we're learning this year. The cube root of 1,000 is 10. And then I take the root number and divide into each of these numbers. So I can bring out a 10. 3 goes into 7 twice, so I can bring out 2 A's, but my remainder is going to be 1, so I have 1 A left inside. 3 goes into 9 3 times, so I can bring out 3 B's. 3 goes into 12 4 times, so I can bring out 4 C's. And I have a cube root of A left over. For this one, if my radicals have the same thing underneath, I can treat them as like terms. So this one is negative 5 square root of 2 plus 10 square root of 2. That is just 5 square root of 2, because negative 5 plus 10 is 5. And then for this one, I have 2 minus 3 square root of 2 squared. So that is a binomial squared. So that means I'm going to write the binomial down twice, and I'm going to use FOIL. And so if I FOIL that, I have 2 times 2 is 4. 2 times negative 3 square root of 2 is negative 6 square root of 2. Negative 3 square root of 2 times 2 is negative 6 square root of 2. Negative 3 square root of 2 times negative 3 square root of 2. Negative times a negative is a positive. 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4. And then I need to simplify. 9 times the square root of 4 is the same thing as 9 times 2. So that's actually 18. And 18 plus 4 is 22. And then these two are like terms. Negative 6 square root of 2 minus 6 square root of 2 is negative 12 square root of 2. Treat those as like terms. So that would be my answer. And here I have a few more. If you have something like this, square root of 3x times 2 plus square root of 5, we're just going to distribute that. So square root of 3x times 2 is 2 square root of 3x. There's really not anything you can do there. They're not both underneath radicals, so that you just combine them to be a radical. There's nothing else you can do. And then square root of 3x times square root of 5, since those are both under the radical, you are allowed to multiply. So that's the square root of 15x. And then if you could bring anything out, you would, but there's nothing that comes out of either one of those, and so that's all you can do with that one. For this one, the 4th root of 2 to the 8th. Now, a lot of times students get confused with that, and they think, well, the only thing I can do is write that thing down 8 times and then combine them all. Well, that's not quite true. You could do it that way, but it's going to take forever. So what you need to realize is if you have that exponent outside of the radical, you can also write it as the exponent being on the inside of the radical. They mean exactly the same thing. There's nothing different about those. All I have to do is divide the 8 by the root number. So 8 divided by 4 is 2. So what we really have here is 2 squared, which is 4. So that's a lot easier and a lot faster than writing it down 8 times. For this one, you need to recognize that if you have a root number to the same power that the root is, the root number and the power cancel each other out. So that would just be 2x. For this one, we're not allowed to have radicals on the denominator. Do you remember how we got rid of a radical on the denominator if we had a binomial underneath? Hopefully you're saying the conjugate. Remember, the conjugate is the conjugate of 3 minus square root of 5 is 3 plus square root of 5. And when we multiply by conjugates, it will automatically get rid of the roots on the bottom because the middle terms cancel out. So I'm going to multiply this thing on the top and the bottom by the conjugate. Now remember, you have to do the same thing on the top and on the bottom, otherwise you've changed the value of the fraction that you started with. So you have to multiply by 1, so we're not changing the value of that function, we're just making it look different, and we do that a lot in algebra. All right, so I'm going to distribute up here. So 5 times 3 is 15 plus 5 square root of 5. And then on the bottom, I have to FOIL those. So 3 times 3 is 9. And then look at what happens to the middle terms. 3 times square root of 5 positive is positive 3 square root of 5. Negative square root of 5 times 3 is negative 3 square root of 5. And square root of 5 times square root of 5, and it's a negative square root of 5 times square root of 5, is a minus 5. Because when we multiply two things that are the same under a radical that is a square root, okay, the square root's going to drop out. And so if you look at this, these are opposites, so they cancel. Now, if you're okay going straight from here to here, I'm fine with that because the middle terms drop out and you get 9 minus 5, which is 4. And then for this one, if I have the square root of 5 squared, well, isn't that the same thing as the square root of 5 squared like that? And the square root and the square cancel each other out. That just gives us 5. Or you could say that's the square root of 25, and square root of 25 is 5. There's a whole bunch of different ways you could do that. I'm fine if you go straight from here to here, too. You don't have to show any work for that one. It's just very simple. Okay, for this one, if I want to simplify the square root of 27, that is the same thing as 3 times 9, and 9 is a square number, so I can bring out the 3. So I've got 3 square root of 3 for that one. And then here, if I want to simplify the 48, well, 48 is 16 times 3, and 16 is a square number. So the square root of 16 is 4, so I can bring out a 4, so that's 12 square root of 3. And then for this one, I need to rewrite that as 2 times the square root of 1 over the square root of 3, and I'm not allowed to have square roots on the bottom. So in order to get rid of that, I multiply by square root of 3 on the top and the bottom, and that gives me 2 square root of 3 over 3, and then I'm just going to rewrite these. Now, 3 square root of 3 plus 12 square root of 3 is 15 square root of 3. So 15 minus 2 square root of 3 over 3. I need both of those to have a denominator of 3. So if I make this have a denominator of 3, remember I have to multiply by bottom and top by 3. So I have 45 square root of 3 over 3 minus 2 square root of 3 over 3. And that is 43 square root of 3 over 3. If the 43 and 3 cancel out, you would do that, but in this case, they don't. For this one, we're going to multiply those binomials together, and we're going to use FOIL to do that. Hopefully you notice at the beginning, this is 3 minus 2 square root of 3, and this is 3 plus 2 square root of 3. Those are conjugates, and remember, anytime you have conjugates, the middle terms are going to drop out. So when you notice right off the bat that they're conjugates, you really don't have to do the whole thing. Really all you have to do is do 3 times 3 is 9, and then understand that if I were to multiply 3 times 2 square root of 3, that would be 6 square root of 3, and negative 2 square root of 3 times 3 is negative 6 square root of 3. That cancels out. And then the last term is minus negative 2 square root of 3 times 2 square root of 3. Negative 2 times 2 is negative 4. Square root of 3 times square root of 3 is 3. So negative 4 times 3 is negative 12. And then you have 9 minus 12, which is negative 3. So that one, in the when you have conjugates, you're going to have everything in the middle cancel, and it will just leave you with an integer, or sometimes it might be a fraction, but it just depends on what they gave you. But the middle term, the radicals, will always drop out when you have conjugates. Then the last thing I want to cover in this section, I want to make sure you see one like this before we go any further. Remember, if you have polynomials underneath a radical, you are not allowed to do this. Don't write this down. This is wrong. You are not allowed to do this. X squared plus the square root of 10x plus the square root of 25. That is completely wrong. There is no rule that says we're allowed to separate things out from radicals that have been added together. You can't do this. That's just totally wrong. If you look at this, remember we, in a couple chapters ago, talked about how to factor. And if you have something that is factorable underneath the radical, that's what you want to do to try to simplify it. So remember, in order for something to come out of a radical, it has to show up twice. So the only way we can get this thing simplified is if when we factor we end up with the same factor twice, okay? So let's try to do that. If I take the square root of this in factored form, well, if you think about it, if I'm trying to factor that, I want factors of 25 that add to give me 10. Well, that's 5 and 5. So I'm going to factor that one. I've got my x and my x. I've got a 5 and a 5. The sign, the plus, tells me they're the same as this, so they're both plus 5. So we've got x plus 5 times x plus 5. Anytime you have two common factors underneath a radical that show up and they're exactly the same, we can bring it out once. Anything that shows up twice, we can bring out once. So the square root of this is just x plus 5.